Everyone, so today I am going to share with you three integrals using special functions. So the first question is in front of you, that is, if it is given that the integration of e to the x over x dx is equal to ei of x. Here ei stands for exponential integral of x. It's just a special notation because the function e to the x over x is not elementary, that is, it cannot be integrated. So if that thing is given, so we have to integrate x times e to the x times ln x. Okay, so let's begin. We are told to find the integration of this function as a whole. So here you can see the multiplication of functions, so we can use integration by parts. So let's differentiate the natural log of x and integrate x times e to the x. So for integration of x times e to the x, we need to do another integration by parts, and in this case I will differentiate x and integrate e to the x. So differentiating x I get 1, and differentiating 1 I get 0. Integrating e to the x I get e to the x and again e to the x, plus minus plus. So this times that and then this times that. So the integration of x times e to the x is equal to x times e to the x minus e to the x. And now what is the derivative of ln x? It's just 1 over x and then plus and minus. So the integration of x times e to the x ln x is equal to x times e to the x ln x minus e to the x ln x, and then this whole row represents an integral, so minus of the integration of, now x and x will cancel, so you have just e to the x dx, and then minus and minus we get plus, plus the integration of e to the x over x dx. So this is as it is. We write it down again. And now what's the integration of e to the x? It's just e to the x. And what's this? Is this the thing that is given? Yes, it is. So we can write ei of x, and then at last don't forget to put the plus c, and then we are done for this question. Okay, so let's begin the integration of our second question. So in the second question we are said that if sin x over x, that is the integration of sin x over x dx, is equal to si of x. That is another special notation because the function here sin x over x is not integrable, or it's not elementary, so we cannot integrate it. And if that is given, we have to integrate 1 over inverse sine of x whole square. So let's begin. We are told to integrate this guy. Yes, dx. Okay, so now let u equal to inverse sine of x. Okay, so from here you can say sine of u is equal to x. You can take the regular sign on both sides, so sine of u and sine and inverse sine will cancel each other. So from here you can say, if you differentiate both sides, you get cosine u du is equal to dx. So now let's substitute all the values. So this integration is now equal to 1 over u square times cosine u du. Okay, now let's do integration by parts because we again get the multiplication of functions. So which one would you like to differentiate and which one would you like to integrate? So I think we should differentiate 1 over u square and integrate cosine u. Now 1 over u square is actually u to the negative 2. So you add 1 to the power, you get u to the negative 1, and then divided by the new power, that is negative 1. So all in all, you get negative 1 over u. And cosine u, integration of cosine is just the positive sign, and then plus and minus this and that. And so this integration is equal to sine u over u square, and then minus and minus will be plus, and the integration of sine u over u du. Okay, now sine u, what is sine u? I think it's x, and u is just inverse sine of x, so we just substitute them. So you get x upon sine inverse of x whole square plus, this is what? Is this what is given? So we can write it as the si of x. So si of u. And what is u? U is again the inverse sine of x. So we are done, and then don't forget to put the plus c, and that's it. So now we have the third question in front of us. This is not any special function, it's just given that if the integration of any function f of x dx is equal to capital F of x, which is a new function, so what will be the value of the integration of f inverse of x? So let's proceed. Solution. We have to integrate f inverse of x. Okay, so I'm going to let u equal to f inverse of x. From here you can say x is equal to f of u. Yes, now if we differentiate both sides, we get dx is equal to f prime of u du. Yes, now let's substitute all these values in the main integration. So the main integral becomes f inverse of x is just u, and then this is f prime of u du. Okay, now let's do integration by parts. We are going to differentiate u and then integrate f prime of u. Now u, when differentiated, will give 1, and the integration of f prime of u will be f of u, and then plus and then minus and then this. So this integral is now equal to u times f of u minus the integration of f of u du. Now u is what? It's f inverse of x, and f of u is just x. It is x times f inverse of x minus, now f of u du. Is it somewhat like this? It is going to be capital F of u, I think so. Yes. And what is u? U is f inverse of x. So we put f inverse of x, and then we are done. So don't forget to put the plus c. And then we are done with this question as well.